Hello, I'm going to be showing off an automotive demo. First thing you're going to want to do is create a new project. GeoStudio is project base and we have project bundles. These project bundles serve as templates for your projects. Here we can see a variety of them. For this project I'm going to do the automotive starter. I'm going to call it automotive demo and I'm going to create the project. What this is going to do is extract it and create a new GeoStudio project based off of our project bundle. So the first thing I'm going to do in our new GeoStudio project is import an existing Photoshop design. Here we have speedometer.psd. I'm going to go and drag and drop it into the editor and see it automatically imported. In our geometry tab, we see that we have a new parent, speedometer. It has two children, speedometer gauge and speedometer needle. These objects were automatically created based off of the layers in the original Photoshop design. Here we also see that we have a magnifying glass next to our speedometer parent object. This means that we are maintaining a connection to the original Photoshop design file. By clicking it, it'll open up the source file. I'm going to drag Photoshop to the right and GeoStudio to the left. Because we maintain a connection to the original Photoshop design file, any changes made to the design file will be automatically imported into GeoStudio. For instance, if I wanted to toggle the visibility of the needle object and save the file, it'll be automatically brought into GeoStudio. It's also important to note that the naming of the layers in the Photoshop design file must follow the naming convention to be brought correctly into GeoStudio. We still want the needle object though, so I'm going to retoggle the visibility, save it, and go back into GeoStudio. To continue the design, I'm going to correct the speedometer needle rotation point. Currently it's in the middle of the needle, so I'm going to go ahead and drag it to the center of the gauge. Next, we want the speedometer pointing at the 0 mark on the gauge, so I'm going to go ahead and drag the rotation vertex to the 0 mark. Now we want to add some interactable objects to our design. To do so, I'm going to use our UI widgets. UI widgets are imported GeoStudio objects that allow you to create GUI-like form in your GeoStudio project. For this project, I'm going to use the UI button and UI slider widgets. UI widgets also have object properties that allow you to customize the look and feel of the widgets. Our UI button widget, if I scroll down here, allow you to customize these properties. I'm going to change the label to manual toggle, which will update the text of the button. I'm also going to enable the toggle property of the button so that it can be toggled. I'm going to run the project, and what's going to happen is it's going to generate C++ source and header files based off of the current deployment. Deployments allow you to iterate and prototype on a variety of platforms, including desktop, embedded, and safety critical. It also runs your application. Here we have a static speedometer, a button that can be toggled, and a slider that can be dragged. Now I'm going to create a connection between our UI widgets and our speedometer. I'm going to go into our calculate function and uncomment some of the code I already had in there. What this code is going to do is it's going to ramp between 0 and 160 by default, and when the button is toggled, it's going to allow the UI slider value to control the speedometer value. So once the application is run, we will expect the speedometer to run by default between 0 and 160. And now if I were to click the toggle button here, we have manual control over it, and I can now drag along the slider to control the speedometer. I'm now going to show off the new GUI testing framework package. The GUI testing framework package allows you to create automated tests that run against GeoStudio applications. I've already created a test named Automotive Demo. The test has 6 steps. The first step sets the value of UI button state to 1, which toggles the UI button. The second runs calculate. The third takes a screenshot. The fourth sets the UI slider value to 50. The fifth runs calculate, and the sixth takes another screenshot. I can run the test by clicking the Run Test button and running the application. This is going to override the application controls and automatically run through the test steps. The test has run and now we have results. I can open those results And on the left here, we see we have test steps. In the middle, we have a test baseline. The test baseline is a previous test run that we were okay with and saved to compare against future test runs. On the right, we have our current test run. If I scroll down, we can see that it's all green, meaning that it matches our previous test baseline. If we wanted to see a change, I could change one of the test steps here. I can go into our step 4 and change 50 to 100 and run the test again. Now, rather than 0 to 80, we should see the gauge go from 0 to 160. Our test results have updated, and we can see that steps 1, 2, and 3 are the same, but steps 4, 5, and 6 have changed. We can also see that the screenshot, rather than pointing at 80, now points at 160, which is our new expected change. We can save these new changes as the new baseline by clicking the Save Baseline button, or we can continue to run and edit the test as necessary until we are satisfied.